Okay, so hey everyone. Today we're going to solve another problem that is LeetCode 9 to 6 flip string to monotone increasing. So it's a medium level problem and it's a popular problem, as you can see the like and dislike ratio. So let's start this problem. So we are given a binary string and it is said to be monotone increasing if it consists of some numbers of zeros, possibly none, followed by some number of ones, also possibly none. So what this line means is the monotone um, So the monotone string could be of this form. So that is 0, 0, 0, 0, and so on till 0. This is first form. Second form, it could be of 0, 0, 0, and then followed by some 1. And third form, it could be of all zeros are, so all ones are present, but there are no zeros. These are the three forms of a monotone increasing string, binary string. So when if we are given this string, you can flip the S of I, changing it from 0 to 1 or from 1 to 0, which means that every bit could be either a set bit or an off bit, which means you can toggle the bit, return the minimum number of flips to make S monotone increasing. So for example, in this case, in this test case, we are given 0, 0, 1, 1, 0, right? At this point, so let's see how we can. So the monotone increasing variations of this string would be, so either all of them are 0, right? Or 0, 0, 1, 1, 1. This is one way of doing it. And the other way is 1, 1, 1, 1, 1, right? So if we are creating this monotone string for this one, then we have to toggle these two bits. If we are toggling these two bits, then the flips required for creation of this monotone string will be 2. So if we are creating this monotone string, in this case, we need to toggle this bit, which means one bit is only toggled, which means one flip is only done and one operation is the cost. And if we are changing it to this monotone string, then we need to toggle this bit and this bit, which means 3 bits are toggled. Out of all of them, right? Out of all of them, the least operations are done, the least flips are done in this case, which means that this is our this is the monotone increasing string that we are looking for, because it requires minimum flips, and this will be my answer. And I don't need to return the string, I need to return the number of flips that I have done, and I'll be returning 1 in this case. So if we talk about another example, let is 0, 1, 0, and then you have 1, 1, 0. In this case, how you can do this? So for this case, there can be a lot of operations, right? But the very intuitive way of solving it would be, if you change this bit to 0 and you change this bit and you flip this bit to 1. So it will be 0, 0, 0, and then you have 1, 1, 1. This is a monotone increasing string, and the number of operations or the number of flips that you need to make are 2. And if you have 0, okay, triple 0, double 1, then you have triple 0 again. Okay, if this is the case, then what you can do is, so in order to make it monotone, you can either flip these bits, but this will give you 3 flips, or you can flip these bits, this will give you two flips. So it will be 0, 0, and these bits are flipped now, 0, 0, and then you have 0, 0 as default. In this case, this is a monotone string, as I have told you earlier that this is a case of monotone string. This is a variant, and the number of flips required are 2. If we are changing these bits, then it will require 3 flips, which means this is the minimum flip and this is our answer, that is 2. How we can do this? So if you have solved an algorithm or a problem named as Cadane's algorithm, that is the continuous uh, that is the continuous subarray sum, the maximum subarray sum. If you have solved this problem, then you might be able to intuitively solve this one as well. But if you have not, then let me give you some hints. So for this problem, we are doing something called DP plus greedy. So it's a like variation or the mix of these two concepts, and these two concepts are very powerful concept, DP and greedy. We'll be mixing them together. So let's see how we can do this. So for example, we are given this test case that is 0, 0, 1, 1, 0, right? And in this test case, what do we have? So in DP, uh, actually it's not a right way of saying it, but in DP what we do is we shorten the input, right? We say that we don't care about these letters, we are just focusing on this one. Okay, so let's do it. Now we are just focusing on this one. So I want you to ignore all these strings, just focus on the current one, that is 0, 1, 2, 3, and 4. Zeroth character. So if we have 0, at 0 we have two things. Either we can toggle it or it can be remain as it is, that is 0. So if what are the ways, why are we thinking about this thing? Why do we think about this and that we need to toggle it or we need to keep it as same? So for example, you are 0, right? You are currently focusing on this string that is 0. If there are, let's say, 1 here, right? If there are 0 and 1 1 1 and then you have 0, so this is the string that you are focusing on. In that case, if you toggle it to 1, right, if you toggle it to 1, then you will be doing one flip. Or if you don't toggle it, then you will be flipping all these ones, which means at 0th position you have a choice of choosing the minimum out of these two things. That was which I said earlier. If you are toggling it, that means the flips that you have already done plus 1, or the number of ones that you have encountered on the left side of this current string will be flipped, which means ones, or let's say number of ones. Out of these two you will be selecting, if you have 0, out of these two you will be selecting, okay, this will be the number of flips that I will be requiring. But if you have 1, then you won't be doing anything. Why you won't be doing anything? Because let's say now we are at this string, right? So this is 0 0 1. This is fine, we don't need to do anything for this case. Why? Because 1 is at the tail of the string, right? 1 is at the tail of the string, so we don't need to do anything, although we need to keep a track. Do we have 1 or not? How many ones do we have? Because we are using number of ones when we encounter 0, which is why we will be keeping a track of the number of ones when we encounter 1. Otherwise there is no computation, there is no flip or anything that we need to take care of. So this is the approach that I'll be doing, and this is very much similar to Cadane's algorithm, DP plus greedy. And so this was the proof that I have given you for the greedy method. And the DP method is, at each position you will be thinking either you want to change it to 1 or you want to change it to 0, or as it is, right? Okay. Now, no, time complexity. So time complexity for this solution will be n, because you will be linearly iterating over all the characters of the string. So it will be n time complexity, and space complexity will be equal to constant. Although some cases, like for me, even my first intuition was to use a prefix sum for the number of ones, but then I realized that we don't require prefix sum. We can just we can just have a variable to keep a track of the number of ones that we have encountered till now. We don't need to have further on information, because in DP we shorten the input, right? That this is something that we can use for our own convenience and reduce the space complexity. So this is the analysis, and let's start the implementation. Now let's say you have int, this is flips initialized with 0, there are no flips in initial point, and the number of ones, yeah, ones is equal to also 0. Now for loop, so let's say you are iterating over every character of s, naming as c, and if c is equal to 1, if it is equal to 1, then you will be incrementing your 1 pointer. No computation is needed, as I told you earlier. But else, if it is equal to 0, in this case you will be computing if flips is equal to minimum of flips plus 1. So flips plus 1 means the current 0th character is flipped to 1, or the previous ones that you have already encountered will be changed to, or are flipped. So if they are flipped, then they will be equal to flips, and if the current character is flipped, then it will be equal to flips plus 1, the already flips that are done, and plus 1. Then we can just simply return flips, and this is it. Okay, it is working and it's submitted. Yes, and it is working fine, and it is optimized, and space complexity is also good, time is also good. So yeah, this was the problem, and I hope you have understood this. And if not, then you can obviously comment below, and I will try my best to help you out. And yeah, that's it. Thanks for watching. Have a good day.